The universe is filled with light. Stars burn across galaxies. Nebulae glow in brilliant color, and distant worlds reflect a faint shine of their suns. When we look up at the night sky, it feels as if space is sprinkled with endless points of brightness. But what we often forget is that most of the universe is not bright at all. Most of it is darkness. Between the stars and galaxies lies an enormous ocean of blackness, a vast emptiness where almost no light reaches. And in some regions, darkness becomes something even deeper, something more extreme. These are the darkest places in the universe, cosmic environments where light struggles to exist, where matter hides, and where the emptiness itself becomes mysterious. Darkness in space is not simply the absence of stars. It is shaped by distance, by dust, by gravity, and by the structure of the cosmos itself. One of the darkest environments begins with something called a dark nebula. Unlike the colorful glowing nebulae we often see in photographs, dark nebulae are clouds of gas and dust so thick that they block the light behind them. They are cosmic shadows, massive regions where starlight is swallowed by interstellar dust. From Earth, they appear as black patches against a brighter background of the Milky Way. These clouds can stretch for dozens of light years, hiding newborn stars inside them. In fact, dark nebulae are often the birthplaces of stars, regions where gravity pulls gas together until nuclear fusion ignites. Darkness, in this sense, is not emptiness. It is a veil, hiding creation within shadow. Another kind of cosmic darkness exists on a much larger scale. Astronomers have discovered that galaxies are not evenly spread throughout space. Instead, they form a vast web, clusters and filaments of matter separated by enormous voids. These cosmic voids are some of the emptiest regions in the universe. They can span hundreds of millions of light years, containing far fewer galaxies than average. Inside a void, the night would be unimaginably dark. There would be no nearby galaxies filling the sky, no dense clusters of stars, only distant points of light, scattered far across an enormous emptiness. These voids are like the deserts of the cosmos, regions where matter itself is rare. They remind us that the universe is structured not only by what exists, but by what does not. Darkness can also exist in the deep intergalactic medium, the space between galaxies where only a few atoms drift per cubic meter. In these regions, the universe is so thin that it is almost nothing at all. Light can travel for billions of years without encountering significant matter. Yet even here, darkness is not absolute. The universe is filled with faint background radiation, the leftover glow of the Big Bang, a ghostly echo called the cosmic microwave background. Even in the deepest emptiness, the universe is never completely dark, but some places come close. Perhaps the most haunting darkness comes from objects that do not shine at all. There are stars that have died, collapsed remnants like black dwarfs, neutron stars, and black holes. A black hole in particular represents the ultimate darkness, a region where gravity is so intense that not even light can escape. But the darkness around black holes is not just visual. It is physical, a boundary in space-time itself. The event horizon is not a surface, but a point of no return, beyond which the universe becomes unreachable. Black holes may be the darkest objects, but they are surrounded by some of the brightest phenomena, as matter falling inward heats up and glows. Darkness and light exist together, intertwined in cosmic extremes. The darkest places in the universe are not simply empty black spaces. They are environments shaped by dust clouds, cosmic voids and gravitational monsters. They are regions where our understanding is challenged, where the absence of light becomes a clue to hidden structures. Darkness is not nothingness. Darkness is part of the universe's story, a silent counterpart to the stars. To truly imagine the darkest places in the universe, we must think beyond what human eyes can normally perceive. Darkness in space is not like darkness on Earth. On Earth, darkness comes when the sun sets, but the atmosphere still scatters faint light, and the world is never fully black. In space, darkness can be absolute, a void without air, without reflection, without warmth. A traveler drifting far from any star would see a sky not filled with blue haze, but with pure blackness, punctuated only by distant points of light. And in the deepest regions, even those points would fade. One of the most profound dark environments is the far future of the universe itself. Astronomers believe that stars will not burn forever. Over unimaginable spans of time, star formation will slow, galaxies will exhaust their fuel, and the cosmos will grow colder and darker. In the distant future, the universe may enter an era called the Degenerate Age, where most stars have died, leaving behind faint remnants. Eventually, even the last starlight may disappear. The universe itself could become a place of eternal darkness, expanding endlessly as light fades away. This idea transforms darkness from a location into a destiny. Another kind of darkness is hidden, not in the absence of light, but in the presence of invisible matter. Dark matter, which makes up most of the mass in the universe, does not emit or absorb light. It cannot be seen directly, yet its gravity shapes galaxies and clusters. In a sense, the universe is filled with a darkness that is not emptiness but substance, matter we cannot observe. The darkest places may therefore not be voids, but regions dominated by unseen mass, shaping the cosmos silently. Darkness also plays a role in the search for life. Planets in deep space, far from stars, may be frozen worlds, yet some could hide oceans beneath ice. Life, if it exists there, would never know sunlight. It would evolve in darkness, sustained by geothermal energy. The universe may contain habitats hidden in shadow, worlds where darkness is normal, where life does not depend on starlight. Even within our own galaxy, there are regions so obscure by dust that visible light cannot pass through. The center of the Milky Way is hidden behind thick clouds, making it difficult to observe with optical telescopes. Yet infrared and radio waves reveal what lies within: dense star clusters, powerful gravitational forces, and the supermassive black hole at the galaxy's core. Darkness here is not emptiness, but concealment. The universe hides its most extreme environments behind curtains of dust and shadow. The darkest places are therefore not simply the absence of stars, but the presence of barriers, distances, and invisible forces. They remind us that the cosmos is not fully illuminated, not fully understood. Light shows us beauty, but darkness shows us mystery. The universe is shaped as much by what we cannot see as by what we can. In the end, the darkest places in the universe are invitations. They invite us to imagine the unseen, to explore the boundaries of emptiness, to confront the hidden architecture of space. Somewhere out there, beyond the glowing nebulae and shining galaxies, darkness stretches endlessly, silent and profound, holding secrets that may take centuries to uncover. The universe is not only a realm of light, it is also a realm of shadow, and within that shadow, the deepest mysteries wait.